So in this video we're just going to look at the difference and similarity between momentum and impulse, what they are and why we need to care. Now before we start, I'm guessing you have some familiarity with forces, mass, velocity, and maybe momentum itself. So before we get started, we're just going to go through a few things to try and explain or really try and get an idea of what momentum and impulse might represent, and then later we'll see how it's related to forces and why it's important to know them. So let's say you have an object and it has a particular mass and is traveling with some velocity, and we're applying some force to it over some period of time. Now in this instance let's assume, for the purposes of this explanation, that we can change the mass of the object or its velocity, and we can change the force or the time that the force is applied over. And what we're interested in is looking at how the velocity changes due to the force. Obviously the reason is because when you study physics, we're studying about how things move, and it's important to know why this happens. Let's start by changing the mass. Let's say we doubled or increased the mass somehow. How does that change the velocity? And more importantly, how much is that change in velocity relative to when we had a smaller mass? The change in velocity would be less than if the mass was smaller. So back at this situation, if we applied the same force, then the change in this velocity would be greater than if we were in this situation, where the mass is bigger. Okay? And you can think about that intuitively as well. If you imagine a massive crate, really massive crate, and you try to push it, basically, it'll be much easier for you to push it than if the crate was less massive. And you can imagine the whole thing in space if you want to get rid of friction and air resistance and all that as well. But the point is that a less massive object is much easier to move with a smaller amount of force. Now, let's consider what if the object was traveling at a greater velocity. Well, in that case, for the same force applied over the same period of time, the change in its velocity would still be less. Okay, it would also be less than if the object was traveling with a slower velocity. What we can see from this is that mass and velocity are kind of related, and we can make them related in a concept known as momentum. It's actually, you can say it's a number. Momentum is basically the mass times the velocity, and we can replace this by just momentum. So we can now look at how momentum changes because a force is applied to an object. Okay, so now let's try and change the force applied to the object. If we make the force applied to the object greater, and the time is still the same, how does its momentum change? Well, in that case, the change in momentum would be much greater than if the force was smaller. Similarly, if we increase the time that we apply the force over, we would see that the momentum, again, there would be a greater change in the momentum than if the time that the force was applied was shorter. Therefore, what we can see is that force and time together affect how the momentum changes, right? And it so happens that these two, this times this, makes up a new quantity called impulse, which is essentially, so I'm coming down here, just the change in momentum. Going over that again, so if we had an object and it has a particular momentum, and we're interested in how that momentum changes, then we'd look at the concept of impulse, which just happens to be, and it kind of makes sense that we've seen it now, it happens to be force multiplied by time, as shown here. Okay, so why do we care about change of momentum or impulse? The reason is, as I said before, in physics, when we're studying how objects are moving, and we're interested in how they would react to, how their motion would react if we applied some force, whether it's like so, or on the bottom, or the side, or the top, we're interested in how does its velocity and how does its momentum, actually not velocity, how does its momentum change. We are interested in velocity, but we can take them together with mass and make up momentum, and we're interested in that, how that changes. Well, let me just quickly mention why are we interested in Why are we interested in mass and velocity in physics? And the reason is because, well, like we saw before, if you had a really massive crate traveling at some velocity, you know that you'll have to apply a much greater force than if the object was less massive. And similarly, if you had a crate of some mass and it was traveling at a much higher velocity, you know you'd have to apply a much greater force to try and slow it down. Okay, that's the reason, because mass and velocity together kind of make up this useful quantity called momentum that we can understand how that changes. Now here's an example that we've seen before. If we consider an egg with some momentum traveling towards some object, in this case it's a hard tile floor, the change in momentum as it hits the ground or as it hits the tiled floor would be some momentum, whatever it's traveling at, minus 0. The reason is because it started off at this momentum, and when it hits the floor it suddenly stops, and it is no longer moving, so it has no velocity. So momentum is mass times velocity, and we know that velocity is now 0, therefore the momentum becomes 0. So therefore the change in the momentum is this minus 0. Okay. Consider if the same object traveling with the same momentum now hits a pillow. In this case, the change in momentum is still whatever it was traveling at, some momentum, minus 0. So we can also say that the impulse in both situations is exactly the same. Okay? Is exactly the same. But now let's consider what force is applied in each situation. In this particular situation, with this particular change in momentum or impulse, we know that this impulse has to be the same. We know that the duration in this case would be extremely short. It would abruptly come to a stop, as you can tell if you experiment yourself. So if this number has to stay the same, if the impulse has to stay the same, and the duration becomes smaller, that means the force would have to become larger. Okay. Similarly, if we have, coming down here, the same object with the same momentum hitting a pillow, we know that the duration is much longer than if it hits the floor. If this number is bigger, this number has to stay the same, this number has to decrease, therefore the force is smaller. And that is why if you land a pillow on an egg, it survives, and if you land a pillow on the ground, it doesn't.